Hello friends, I am back with a new problem today. So far what I have problems I have taken was mostly without friction, right? In the Newton's laws of motion problems which we solved in the past, they were not having friction, their surfaces were smooth. This problem we have I'm starting a new uh, problem series where we are going to consider frictions also. So the problem says the friction coefficient between the board and the floor is mu. How much maximum force the man can exert so that the board does not slip, assuming pulleys are massless. Okay, so if you see the diagram, this person is holding this string, right? So he can pull this down, right? If he pulls this down, what will happen? Let's understand the different forces acting here. So if he pulls this down, there will be tension in the string, right? So tension, if he applies force on the string, from Newton's third law of motion, the string will also apply force on the man, which will be opposite in direction. So man is pulling the string down, so string will pull the man up with the same magnitude, right? So consider tension in the string is T. So T with the same tension, the string will pull man upward. And since all these three pulleys are massless, just remember the tension in all the three sections or all the four sections of the thread will remain the same because pulleys are massless. We can prove this using rotational mechanics probably in some time in the once we have a problem in the rotational dynamics, rotational mechanics types of problem, then we can prove. There you will see pulley will have mass and some moment of inertia, so tension will not remain the same. But here, since pulleys are massless, the tension will remain same across all the section. So this T, and then now we'll see. This is the body on which he is standing, which is mass is small m. So as you know, first thing we should start is we should start drawing free body diagram, right? So let's start drawing the free body diagram of the man. Free body diagram of man. So on this one, what forces are upworking. So let us say this is his center of mass, right? So there will be its weight mg downward. Then tension, right? Tension is working, pulling the man upward. So you can show here tension is pulling the man upward with T. What else? Anything else you see here? There is one more force. He is standing on this plank, right? So plank will also exert a normal force upward because he is standing on the plank, so he is pushing the plank down. So plank will also push him upward from Newton's third law of motion with same magnitude. So let's assume that plank is pushing the man upward with a normal force N. What else? Tension. Tension is working on the plank, right? So what is happening is uh, friction and this tension, I think we will consider once we draw the free body diagram of the small m. On the man, I don't think any other force is working. So T is upward, normal force is upward, and weight is downward. Okay. So now let's apply the Newton's first law of motion. Because the whole system is static, there is no acceleration. So all forces should balance, right? So apply Newton first law of motion along vertical direction. Okay, So what will happen? N upward plus T upward equal to mg, first equation, and along horizontal direction, if you see, there is no force, no force, right? So no need to have an equation because you cannot have. Now let's draw the free body diagram of the blank M. Free body diagram of blank M. Just see this. So this is the plank. What is happening here? So this plank is exerting a normal force N on the person. So person is also exerting a normal force N in the opposite direction. It will be down. Then it has its own mass M. So its mass, because of its mass, there will be a weight of this plank downward, mg. And then surface, the ground will also exert some upward force, right? Some, let us say N dash. And there is a tension here, right? T. The string is pulling towards right with T. Now tell me in which direction the friction force will apply. Just remember, forget all these forces. Just remember the horizontal forces. So horizontal force is T, which is working towards right. So because of this force, the plank has a tendency to move towards right. Since it has a tendency to move towards right, though it's not moving, right? Because the system is static. Though it's not moving, but it has a tendency that because of this force, it we can move. If you increase the force, it can move towards right. So friction will oppose this tendency, and friction will work towards left. Always remember, friction opposes the motion, right? And friction, static friction is self-adjustable. So it will keep increasing its value up to some maximum limit, right? Mu times n. So let's now uh, have the Newton's first law of motion along the vertical direction for this for this plank. I'll just write in short form for vertical equilibrium. What is going to happen? N dash upward and downward is N plus mg, right? Let's make equation number 2 for horizontal equilibrium. It's in equilibrium, right? Because system is not moving. So friction force F should be equal to T. But we know friction force F is mu times normal force, right? And normal force is N dash here. So F is T equal to mu times N dash. So you got the value of T, equation number 3. So how many unknowns we have? We have T, N dash and N. Three unknown and we have three equation. So we can solve it, right, easily. Now this physics is over. Now it's a mathematics. You can just solve this three equation and get the value of T. So from 2 and 3, N dash equal to N plus mg, right? This gives N equal to N dash minus mg. Put this value of N into equation 1. N into equation 1. Equation 1 is 1 minute. Equation 1 is N plus T equal to mg. So N plus T. It means N dash minus mg plus T. T also we found mu N dash equal to mg, capital Mg. Now let's see. Try to find out the value of N dash. Let's take N dash common. 1 plus mu equal to, bring this mg this side. You will get m plus small m into g. So N dash you got m plus m g divided by 1 plus mu. So you got the value of n dash, and then t you can find out, right? T will become mu times n dash. So it will become mu times n dash, which is mu g m plus m by 1 plus mu. So this is the value of tension which is being created by the man because he is pulling the thread, right? He is pulling the thread with some force. Because of that force, thread is also thread is also pulling him upward in the opposite direction. So this is the same force which he can apply up to the maximum limit by till when he will not move. The plank will not move. What will happen if he applies more than this value? What will happen is this T will exceeds the frictional opposing force, and then the block and the whole system will start moving. Okay, so this is the maximum force you can apply. That's the answer. I hope you understood and you learned something from today's problem. If you uh, getting some understanding, and then if you're learning from this video, keep liking and keep sharing with other friends, and don't forget to subscribe. Okay, we'll meet into the next video. Till then, bye bye.